Hello students, I am Ekta. Let's recall the previous lesson. An expression that represents repeated multiplication of the same factor is called a power. The exponent corresponds to the number of times the base is used as a factor. The positive exponential notation with positive power could be useful when we come across large numbers. Any non-zero number raised to 0 exponents must result in 1. Thus, a to the power 0 is equal to 1 where a is not equal to 0. In this part, we are going to learn the laws of exponents, standard form and scientific notation. Learning objectives. After completion of this lesson, you will be able to know to understand the laws of exponents with integral powers. To identify and express the numbers in scientific notation. Keywords from this lesson. Positive numbers, negative numbers, addition, product, laws, integers, scientific notation, powers, and exponents. Product law. According to this law, when multiplying two powers that have the same base, we can add the exponents. That is, a to the power m into a to the power n is equal to a to the power m plus n, where a, m and n are integers. A is not equal to 0. Note that the base should be the same in both quantities. Examples. 2 to the power 3 into 2 to the power 2 is equal to 2 to the power 5 by law, meaning 8 into 4 is equal to 32. And note that it is not 2 to the power 3 into 2. Minus 2 to the power minus 4 into minus 2 to the power minus 3 is equal to minus 2 to the power minus 4 plus minus 3 by law, and so is equal to minus 2 to the power minus 7. Or minus 2 to the power minus 4 into minus 2 to the power minus 3 is equal to 1 by minus 2 to the power 4 into 1 by minus 2 to the power 3 is equal to 1 by minus 2 to the power 4 into minus 2 to the power 3 is equal to 1 by minus 2 to the power 4 plus 3 is equal to 1 by minus 2 to the power 7. Is equal to minus 2 to the power minus 7. Minus 5 to the power 3 into minus 5 to the power minus 3 is equal to minus 5 to the power 3 minus 3 by law, and so is equal to minus 5 to the power 0 is equal to 1. Quotient law. According to this law, when dividing two powers that have the same base, we can subtract the exponents, that is, a to the power m by a to the power n is equal to a to the power m minus n. Where a is not equal to 0, m, n are integers. Note that the base should be the same in both quantities. How does it work? See the following examples. Examples: minus 3 to the power 5 minus 3 to the power 2 is equal to minus 3 to the power 5 minus 2 by law. And minus 3 to the power 3 is equal to minus 27. Or minus 3 to the power 5 minus 3 to the power 2 is equal to minus 3 to the power 5 into minus 3 to the power minus 2 is equal to minus 3 to the power 5 minus 2 is equal to minus 3 to the power 3 is equal to minus 27. Or minus 3 to the power 5 minus 3 to the power 2 is equal to minus 3 into minus 3 into minus 3 into minus 3 into minus 3 by minus 3 into minus 3 is equal to minus 3 minus 3 minus 3 is equal to minus 3 to the power 3 is equal to minus 27. Minus 7 to the power 100 by minus 7 to the power 98 is equal to minus 7 to the power 100 minus 98 by law. And minus 7 to the power 2 is equal to 49. Or minus 7 to the power 100 by minus 7 to the power 98 is equal to minus 7 into minus 7 into minus 7 into 100 times by minus 7 into minus 7 into minus 7 into 98 times. Is equal to minus 7 into minus 7 is equal to 49. Power law. According to this law, when raising a power to another power, we can just multiply the exponents. A to the power m whole power n is equal to a to the power mn, where a is not equal to 0, m, n are integers. Examples: minus 2 to the power 3 whole power 2 is equal to minus 2 to the power 3 into 2 by law. and minus 2 to the power 6 is equal to 64. Minus 2 to the power 3 whole power 2 is equal to minus 2 into minus 2 into minus 2 to the power 2 is equal to minus 8 to the power 2 is equal to 64. Verify the following rules as we did above. Here, a and b are non-zero integers and m and n are any integers. Number 1. Product of same powers to the power of product rule. A to the power m into b to the power m is equal to ab to the power m. Number 2. Quotient of same powers to the power of quotient rule. A to the power n by b to the power m is equal to a by b to the power m. Number 3. Zero exponent rule. A to the power 0 is equal to 1. Let's verify the above rules. Let's take a is equal to 2, b is equal to 3, m is equal to 2 and applying values in the above rules, we get number 1. A power m into b power m is equal to 2 power 2 into 3 power 2 is equal to 4 into 9 is equal to 36. Is equal to 2 into 3 whole power 2. Number 2. A power m by b power m is equal to 2 power 2 by 3 power 2. Is equal to 4 by 9 is equal to 2 by 3 whole power 2. Number 3. A power 0 is equal to 2 power 0 is equal to 1. Example. Simplify and write the answer in exponential form. 3 power 5 divided by 3 power 8 whole power 5 into 3 power minus 5. Solution. 3 power 5 by 3 power 8 whole power 5 into 3 power minus 5. Here 3 is common in numerator and denominator. So, is equal to 3 power 5 minus 8 whole power 5 into 3 power minus 5. We get is equal to 3 power minus 3 whole power 5 into 3 power minus 5. Use a to the power m, a to the power n rule. Then we get is equal to 3 power minus 3 into 5 into 3 power minus 5 is equal to 3 power minus 15 into 3 power minus 5 is equal to 3 power minus 15 minus 5 Finally, we get is equal to 3 power minus 20. Example. Find x so that minus 7 whole power x plus 2 into minus 7 whole power 5 is equal to minus 7 whole power 10. Solution. Minus 7 whole power x plus 2 into minus 7 whole power 5 is equal to minus 7 whole power 10. By adding the powers, we get minus 7 whole power x plus 2 plus 5 is equal to 7 whole power 10. Since the bases are equal, we equate the exponents to get x plus 7 is equal to 10. X is equal to 10 minus 7 is equal to 3. So, x is equal to 3. Now, let's see standard form and scientific notation. The standard form of a number is just the number as we normally write it. We use expanded notation to show the value of each digit. That is, it is exhibited as a sum of each digit duly multiplied by its matching place value, like ones, tens, hundreds, etc. For example, 195 is in standard form. It can be expanded as 195 is equal to 1 into 100 plus 9 into 10 plus 5 into 1. Astronomers, biologists, engineers, physicists, and many others come across quantities whose measures require very small or very large numbers. If they write the numbers in standard form, it may not help us to understand or make computation easily. Scientific notation is a way to make these numbers easier to work with. To write in scientific notation, follow the form s into 10 power 8, where s is a number, integer or integer with decimal between 1 and 10, but not 10 itself, and a is a positive or negative integer. Thus, a number in scientific notation is written as the product of a number, integer or integer with decimal, and the power of 10. We move the decimal place forward or backwards until we have a number from 1 to 9. Then we add a power of 10 that tells how many places you move the decimal forward or backwards. Examples. See some examples of standard form and its scientific notation. 0.00123 1.23 into 10 to the power minus 3, 0.0123 1.23 into 10 to the power minus 2, and so on. Some more examples. The diameter of the Earth is 12756,000 miles. This can be easily written in scientific form as 1.2756 into 10 power 7 miles. The volume of Jupiter is about 14330 and so on kilometer cube. This can be easily written in a scientific form as 1.433 into 10 power 14 kilometer cube. The size of bacterium is 0.00 so on 85 mm. This can be easily written in a scientific form as 8.5 into 10 power minus 7 mm. From this, we know the positive exponent in 1.3 into 10 power 12 indicates that it is a large number. The negative exponent in 7.89 into 10 power minus 21 indicates that it is a small number. Let's see some example. Write the following scientific notations in standard form. 2.27 into 10 power minus 4. 2.27 into 10 power minus 4. We can write this is equal to 0.000227. Light travels at 1.86 into 10 power 5 miles per second. Light travels at 1.86 into 10 power 5 miles per second. We can write is equal to 186,000 miles per second. Write in standard form. Mass of planet Uranus is 8.68 into 10 power 25 kg. Mass of planet Uranus is equal to 8680 and so on kg. Write in scientific notation. 0.00 so on 12005 is equal to 1.2005 into 10 power minus 5. Four 312.345 is equal to 4.312345 into 10 power 3. Zero 0.10524 is equal to 1.0524 into 10 power minus 1. Thanks for watching.